Greetings students. Today we will start with Hooke's law. In last class we have studied about the stress strain, the type of stress, tensile stress, shearing stress, volume stress and strain. Now today we start with the Hooke's law. So as per the Hooke's law, stress is directly proportional to strain stress equal to, if we remove the proportional sign, a constant K will come into strain. Here the K is proportionality constant this proportionality constant will be known as modulus of elasticity. Modulus of the Hooke's law is found to be valid for most material. However, some materials are there which do not exhibit this linear relationship. Now, on the basis of Hooke's relationship, we will draw a stress-strain curve. Okay, we will draw a stress-strain curve for a typical metal. Let's see. We take stress on one axis, vertical one, strain on another. This is typical stress-strain curve. For a metal, and it will come as follows. The relationship will be linear initially. We'll draw a few important points on this curve: A, B, D. The relationship between stress and strain for a given material under tensile stress we can found with experiments, and we can plot a graph between stress and strain. Strain stress curve definitely vary from material to material, and these curves help us to understand how a given material deforms with we give a different kind of stress, and the reason is between O to A. Okay, how they deform. From O to A we have a linear curve. The O point is the origin. So from O to A we have a linear curve. Here the Hooke's law is obeyed. Okay, Hooke's law is obeyed. So the body will remain under stress, and when we remove the stress, the body regain its original dimensions. Okay, whenever we removing applied force, the body will regain the original dimension till point O to A, and this region will behave in this region the body, the object, the solid will behave as elastic body. Okay, the point A will be called the proportional limit, the point of proportional limit. Okay, and then the next region from A to B the stress and strain are not proportional. Okay, we will write over here from A go to A, the Hooke's law will be obeyed. Is obeyed. From A to B, strain and stress are not proportional. Nevertheless, the body will still return to the original dimension when the external force will be removed till the point B, and the point B will be known as the yield point or the elastic limit. So we will write that point B will be known as yield point. Okay. Or elastic limit, and the corresponding stress at this moment will be known as yield stress or yield strength. My apologies, the corresponding stress will be known as yield strength, and if we increase the force further, then for a small change in applied force there will be rapid increase in strain. If I am increasing the stress smaller, the small change in stress will yield me the rapid increase in strain, and that portion will be shown between B and D. Okay, and at this moment, okay, we will write first between B to D. Okay, for a small change, we'll write down from B to D. For a small change in stress, there will be a rapid increase or sharp increase in strain, and between B and D, let's say C point, the body does not regain its original dimension. Okay, in this case, if I remove the force, the stress will be zero, but strain will not be zero. Okay, so if there would be any deformation, that will be permanent. So we can say the dimension said to be called the plastic dimension. The deformation said to be called the plastic deformation. Okay, so between B and D, the deformation will be permanent, and it is said to be plastic deformation. And point D on the graph will give us tensile strength of the material. On graph is the ultimate tensile strength. It will be known as sigma u. Beyond this point, at point E, the small stress will produce a larger strain and ultimately fracture the object. Okay, I'm repeating, beyond this point, additional strain is produced even a reduced applied force by a reduced applied force. Okay, if I reduce the applied force, then also there would be strain produced, and ultimately the fracture will occur at point E. Okay, so we can explain as follows. The conclusion of this graph is, if the point D, will see the graph first, the point D and E are closer, the material is said to be brittle, and if they are far away, the material is said to be ductile. Okay, so that is the strain stress curve. In next session, we'll I will study about elastic modeling, Young's modulus. Thank you.